Barrelé fish. Few animals feel stranger than the barrelé fish, a deep-sea marvel first described in 1939, but only truly filmed alive in 2009 by the Monterey Bay Aquarium Research Institute. What sets it apart is its transparent dome-shaped head, inside of which two tubular green eyes sit like floating periscopes. Unlike most fish, whose eyes are fixed in place, the barrelé can rotate its eyes upward to spot prey silhouetted against faint light from the surface, or forward to focus on food drifting in front of its mouth. Its eyes even contain a green pigment thought to filter sunlight from above, helping it see faint bioluminescence. Imagine having a built-in night vision scope permanently locked inside your skull. That's its reality. The fish itself only grows to around 15 centimeters, 6 inches long, but its alien look makes it unforgettable. For decades, scientists believed its eyes were fixed forward. Only live footage revealed they pivot inside the transparent shield, a discovery that overturned decades of assumptions. Living at depths of 600 to 800 meters, 2,000 to 2,600 feet, it floats almost motionless, conserving energy in a world where food is scarce. Its strange head shield may protect its eyes from the stinging tentacles of siphonophores, colonial jellyfish-like predators whose drifting arms can be longer than skyscrapers. In one animal, you see the story of the deep, survival through design so bizarre, it almost defies belief. Leafy sea dragon. Off the southern and western coasts of Australia drifts a creature so improbable it feels handmade by myth, the leafy sea dragon. First described in 1859, this relative of the seahorse doesn't just hide, it vanishes in plain sight. Its body sprouts elaborate leaf-like appendages, perfectly mimicking floating seaweed in surge and current. For predators, it's a ghost. Unlike most fish, leafy sea dragons don't use their fins to dart quickly. Instead, tiny, nearly invisible pectoral fins ripple like transparent sails, allowing them to glide gracefully. They measure around 20 to 24 centimeters, 8 to 9.5 inches, long, though some reach over 35 centimeters, 14 inches. Despite their delicate look, their camouflage is so effective that even divers can hover within arm's reach and never spot them. These animals are also part of a rare parenting story. Like seahorses, it's the male that carries the eggs. A male leafy sea dragon can host up to 250 bright pink eggs under his tail until they hatch, protecting the next generation in a biological role reversal few animals share. Conservationists warn, however, that they're under threat. Their populations are vulnerable due to habitat loss in Australia's kelp forests, which have declined by more than 60% in some areas. Because of their rarity and fragile habitats, they are Australia's official marine emblem, a symbol of uniqueness worth protecting. Every sway of its leaf-like body is proof that survival in the ocean isn't always about teeth and size. Sometimes the best weapon is beauty that deceives the eye. Giant isopod. When Victorian explorers first dredged one up in 1879 off the Gulf of Mexico, scientists could hardly believe it was real. The giant isopod looks like a pill bug scaled up to nightmare size, and yet it's one of the deep sea's most efficient survivors. Most grow around 19 to 36 centimeters, 7.5 to 14 inches. But record specimens have reached over 50 centimeters, 20 inches, long. With a rigid, segmented exoskeleton and 14 legs, they scuttle across the seafloor like armored tanks. Their closest land relatives are the tiny woodlice you find under garden rocks. Just imagine one of those blown up to the length of your forearm. Life for them is mostly scavenging. They feed on whale carcasses, dead fish, and even the remains of squid that drift down from above. Because meals are unpredictable, they've evolved to gorge when food appears. One captive giant isopod famously went 5 years without eating in a Japanese aquarium, baffling researchers and proving just how slowly they can burn through stored energy. Despite their creepy look, they play a vital role as the deep sea's cleanup crew, preventing oceans from filling with decay. They're also incredibly tough. Pressure at their usual depths, 170 to 2,140 meters, 560 to 7,020 feet, would crush most surface creatures. Yet their thick shells and slow metabolism make them nearly indestructible. Instead of speed or stealth, their strategy is patience, waiting out the void of the deep until opportunity drops from above. It's a lesson in endurance written into armored flesh. Dumbo octopus. In 1999, when researchers first filmed one gliding at over 3,000 meters, 9,800 feet, below the surface, the world saw a cephalopod that looked nothing like the squids and octopuses we knew. Named after Disney's Dumbo for its large, ear-like fins, the Dumbo octopus thrives where few animals dare to exist, sometimes as deep as 7,000 meters, 23,000 feet, making it the deepest living octopus known. These octopuses are small compared to giants like the colossal squid. Most are 20 to 30 centimeters, 8 to 12 inches, long, though some stretch past 1.8 meters, 6 feet. Unlike many cephalopods, they lack an ink sac because in pitch-black waters, clouds of ink are useless. Instead, their survival hinges on stealth and gentleness. They hover gracefully, flapping their fins like wings, drifting over the seabed in near silence. Their diet is simple but effective. Worms, amphipods, and tiny creatures plucked whole and swallowed, since they don't tear prey apart like shallow-water octopuses. Scientists even observed a Dumbo octopus swallowing prey larger than its beak whole, stretching its body like elastic to accommodate the meal. What fascinates researchers most is their reproductive strategy. Females carry eggs in different stages of development all at once, releasing them year-round whenever conditions are favorable. That's rare in the cephalopod world, where many species reproduce only once before dying. In a world colder than ice and darker than midnight, Dumbo octopuses move like gentle apparitions. And yet beneath the cuteness lies an animal built for survival in Earth's harshest frontier, blobfish. In 2003, when Australian trawlers pulled up a gelatinous pink lump from waters off New South Wales, photos quickly spread online and the blobfish was crowned the world's ugliest animal. But that reputation comes from a trick of physics, not biology. Living at depths between 600 and 1,200 meters, 2,000 to 3,900 feet, blobfish are perfectly adapted to survive under pressures up to 120 times greater than at sea level. Down there, they don't look like sad balloons. They resemble normal fish with firm bodies. The problem arises when they're hauled to the surface. Without the crushing pressure, their bodies collapse into the squishy caricature we recognize. Instead of bones and heavy muscles, blobfish rely on a jelly-like flesh slightly less dense than seawater. That makes them perfect floaters, drifting just above the seafloor, conserving energy while waiting to gulp down crabs, sea urchins, or mollusks. They rarely swim actively. Their bodies are built for survival in an environment where calories are scarce. Interestingly, the blobfish has become a conservation mascot. In 2013, it was voted the official symbol of the Ugly Animal Preservation Society, reminding people that even unglamorous creatures deserve protection. Deep-sea trawling remains its biggest threat, as nets accidentally sweep up blobfish populations. So, the truth is stranger than the joke. In their rightful home, blobfish aren't ugly at all. They're perfectly engineered for one of the most hostile environments on Earth. Salp chains. In 1910, naturalists studying the waters near Sicily described shimmering strings drifting in the currents, what looked like chains of glass beads stretching for meters. These were salps, barrel-shaped filter feeders related to tunicates, and among the ocean's most alien-looking architects. A single salp measures anywhere from 1 to 10 centimeters, 0.4 to 4 inches, but they rarely live alone. Instead, they form colonies that can stretch over 15 meters, 50 feet, pulsing through the water in unison like a living conveyor belt. Each tiny salp filters seawater through its gelatinous body, straining out phytoplankton. Together, chains can pump thousands of liters of water a day, helping regulate ocean ecosystems. They're also surprising players in climate history. Salps produce carbon-rich fecal pellets that sink quickly, pulling significant amounts of carbon dioxide out of the atmosphere and locking it in the deep sea. During massive blooms, salp populations can spike from a few dozen to thousands in just days, altering entire food webs. Despite their fragile appearance, salps are efficient survivors. They alternate between solitary and colonial life stages, a reproductive strategy that allows explosive population growth under the right conditions. Sailors in the past mistook them for glowing sea snakes or enchanted chains, while modern divers often describe them as swimming chandeliers. These creatures remind us that not every marvel of the ocean comes with teeth or armor. Sometimes it's the delicate, collective life forms that change the planet in silence. Sarcastic fringehead. In 1858, this bizarre fish was first catalogued off the coast of California, but even seasoned ichthyologists struggled to believe its behavior. At first glance, the sarcastic fringehead looks unremarkable, growing just 7 to 30 centimeters, 3 to 12 inches, long. Yet when provoked, it reveals one of the most shocking displays in the fish world, a mouth that bursts open into a fan-like maw wider than its body, lined with needle-like teeth. This isn't just for show. When two males meet in a territorial dispute, they don't bite or wrestle. Instead, they press their giant, rainbow-hued mouths against each other, like some surreal kissing contest, until one retreats. Scientists call it mouth fencing. The winner holds the rocky crevice or abandoned shell it calls home, prime real estate in coastal waters from San Francisco down to Baja California. They're fiercely territorial. Divers report fringeheads charging at intruders many times their size, including human hands, cameras, and even passing octopuses. Their scientific name, sarcastic, doesn't mean witty. It comes from the Greek sarkastes, meaning to tear flesh. Fringeheads feed on fish, crabs, and squid, darting out of their lairs like underwater jack-in-the-boxes. They've even been found hiding in soda cans and bottles tossed into the sea, proof of how resourceful they are in adapting to human-altered habitats. Behind the comical look is a predator that defends its turf with ferocity out of proportion to its size. One wrong move, and those jaws turn spectacle into weapon. Vampire squid. When scientists first described it in 1903, they gave it one of the most dramatic names in taxonomy, Vampiroteuthis infernalis, literally, vampire squid from hell. The truth is less bloody but even stranger. Living at depths of 600 to 1,200 meters, 2,000 to 4,000 feet, where oxygen is nearly absent, the vampire squid survives in conditions that kill most other animals outright. It grows only 15 to 30 centimeters, 6 to 12 inches long, but its design is unforgettable. Its 8 arms are connected by webbing that forms a cloak-like membrane, and inside the cloak are spiny projections that make it look like a living umbrella of thorns. Unlike true squids, it has no ink sac. Instead, it releases bioluminescent mucus, glowing blue sparks that can dazzle predators for up to 10 minutes. Its diet surprised scientists. Instead of hunting like other squids, it drifts through the depths, collecting marine snow, a rain of organic particles, fecal pellets, and tiny carcasses. In essence, it's a recycler of the dead zones, thriving where few creatures dare. To conserve energy, its heart rate slows drastically, and its muscles are weak compared to shallow water relatives. Yet it compensates with sensory filaments that unfurl like fishing lines, detecting faint vibrations in the dark. The vampire squid is less Dracula and more endurance artist, a reminder that in the abyss, survival doesn't always mean ferocity. Sometimes it means turning death itself into fuel for life. Gulper eel. When deep-sea trawlers first hauled one up in the late 19th century, Scientists thought it had been deformed in the net. Its jaw seemed impossibly large for its body. But the gulper eel really is built this way. A slender, whip-like fish with a ballooning mouth that can open wide enough to engulf animals half its size. Most adults stretch around 0.6 to 1 meter, 2 to 3.3 feet, long, though some specimens approach 2 meters, 6.5 feet. Their jaws are hinged like a trap, and when opened, the mouth cavity forms a pouch almost as big as their entire body. Unlike most predators, they don't rely on teeth to shred prey. Instead, they swallow victims whole: fish, squid, even crustaceans that happen to drift too close. The gulper eel also carries its own lantern. At the tip of its tail glows a pinkish, bioluminescent bulb that can flash or pulse. Scientists believe it works like a lure, drawing curious animals into striking range, not unlike an anglerfish, but with a very different body plan. Living at 500 to 3,000 meters, 1,600 to 9,800 feet, gulper eels occupy one of the darkest and coldest habitats on Earth. Their stomachs are elastic, able to expand like balloons, letting them store large meals when food is scarce. One study even noted stomachs filled with dozens of small shrimp, crammed like sardines in a can. They're living paradoxes, fragile in frame, yet engineered to devour beyond their size. In the deep sea, where scarcity rules, their grotesque design is the ultimate insurance policy. Sea pig. First described in the late 19th century by Swedish zoologist Hjalmar Thael, the sea pig immediately confused scientists. Technically, it's a deep-sea sea cucumber, but its squat body and tube-like legs make it look more like a pink toy pig waddling on stilts. Found at depths between 1,200 and 5,000 meters, 4,000 to 16,500 feet, sea pigs thrive in places where pressure would crush submarines and temperatures hover near freezing. Their bodies are rarely longer than 15 centimeters, 6 inches. But what makes them unforgettable is their behavior. They often gather in herds of hundreds or even thousands, carpeting the seafloor like a living tide. Their legs aren't for walking in the usual sense. They're hydraulic tube feet, powered by water pressure. This lets them trot across mud in search of their primary diet, decaying matter, especially whale falls. They can detect the chemical signature of a dead whale from kilometers away, homing in like vultures of the abyss. Even stranger are their spindly antenna-like appendages, sensory organs that sweep the sediment for food cues. Some species host tiny parasites called parasitic snails, gastropods of the genus Eulimidae, that latch onto their skin and feed on their fluids, turning these already odd creatures into moving buffets. For deep-sea biologists, sea pigs are more than curiosities. They're indicators of seafloor health. Their presence or absence tells scientists how nutrients move through ecosystems that remain some of Earth's least explored. The irony? A creature so small and squishy commands such outsized fascination, proving again that the ocean saves some of its greatest surprises for the tiniest bodies. Axolotl. In the lakes around Mexico City, the Aztecs once worshipped a salamander they believed embodied Xolotl, the god of death and lightning. That animal still exists today, the axolotl, also called the Mexican walking fish, though it's no fish at all. Unlike most amphibians, axolotls never complete metamorphosis. Instead of shedding their gills and moving onto land, they remain permanently aquatic and larval, a process called neoteny. This means adults keep their feathery pink gills, baby-like faces, and small stubby legs even when fully grown. Most measure 23 centimeters, 9 inches, though some individuals stretch up to 45 centimeters, 18 inches. The real miracle, though, is regeneration. Axolotls can regrow entire limbs, tails, spinal cords, parts of their eyes, and even chunks of their brains, without scarring. Scientists have studied them for decades, hoping to unlock secrets of regenerative medicine. In lab conditions, they've replaced the same limb as many as 5 times, each one perfectly formed. Historically, axolotls were abundant in Lake Xochimilco and Lake Chalco, but centuries of habitat loss and urban expansion nearly wiped them out. Today, wild populations are critically endangered, with densities dropping from 6,000 per square kilometer in 1998 to just 36 per square kilometer by 2014. Most axolotls you see in pet stores or labs are captive bred. Despite their peril, they've become global symbols of resilience. Their eternal youth, almost cartoonish look, and supernatural healing abilities blur the line between biology and myth, earning them nicknames like water monsters and living Pokémon. Christmas tree worm, first described scientifically in 1758 by Carl Linnaeus, the Christmas tree worm has enchanted divers and baffled scientists for centuries. At first glance, you see 2 colorful spirals, red, blue, yellow, or white, sprouting from coral like miniature holiday decorations. But those spirals aren't the worm itself. They're specialized feeding and breathing appendages, called radioles, used to filter plankton from the water and absorb oxygen. The real worm lives hidden inside a self-made tube, bored deep into coral skeletons. Most grow only about 3.8 centimeters, 1.5 inches, long, yet their tubes can extend deeper than 10 centimeters, 4 inches, like secret bunkers within the reef. They cement themselves in place permanently. Once settled, a Christmas tree worm never leaves its coral home. What makes them remarkable is their lightning-fast reflex. If disturbed, the spirals vanish into their burrows in less than 1/10 of a second, sealing the hole with a protective trapdoor called an operculum. That reflex has helped them survive countless coral predators. They're also living records of reef health. Found in tropical waters worldwide, from the Caribbean to the Indo-Pacific, their abundance often signals coral resilience. Yet, as bleaching events intensify, killing reefs across the globe, Christmas tree worms are disappearing along with their hosts. Despite their fragility, they've become icons of underwater tourism. Entire dive trips center around spotting these tiny marvels, proving once again that size doesn't dictate wonder. In a sea filled with giants, sometimes it's the little flashes of color that remind us how strange, delicate, and irreplaceable ocean life really is. Thanks for diving into the ocean's strangest wonders with me. Proof that Earth's depths rival any science fiction. If you enjoyed the journey, subscribe and like. More hidden worlds wait in the next story. Let's keep exploring together.